Okay, fine. So today we are going to learn about some basic concepts of chemistry. And in that, very important topic has been there, which is really very important for the JEE and as well as NEET. That is nothing but a mole concept. This concept you have learned in your grade 9. Do you remember anything about it?
Yes, ma'am.
Yeah. Can you elaborate what you remember about it? Any one of you? Let me see. What is there in your mind? Can you recapitulate it? Pritam?
Amount of mass.
Okay, atomic mass, very good. That is there. What is there on the page that only you don't read? Please try to memorize and tell me what you have learned in that. I hope many of you have learned about the molecules, correct? Yes, you might have learned about the atomicity, right? Then Dalton's theory, you might have learned laws of conservation, laws of chemical combinations you have learned in that chapter, where you have learned about the law of conservation of mass and law of chemical combination, correct? Constant proportion, isn't it? Loweiser's law, Loweiser and Proust's law. You learned it or not?
Dalton's atomic scale. Ma'am.
Yes, Pritam, I'm not able to hear you. Can you please speak a little louder?
No.
Hello?
Hello.
Yeah, you said something, but then it wasn't audible to me. I couldn't hear it.
The laws, conservation of mass and all.
Mass.
That definite proportions and
Okay, do one thing, please type it in your chat box. So I'll get to know what you want to say. Okay, only a small question for you all. Am I audible clearly with you all, or anybody is facing difficulty to hear me? Or else I'll switch off my ceiling fan.
You're audible, ma'am.
Okay. Need not to do anything, right?
Yes, ma'am.
Okay. Okay, fine. So we are going to learn about the atom, atomic mass, relative atomic mass, then how relative atomic mass, what is the reference standard to find out the relative atomic mass? Okay. What is the molecular mass? What is the formula unit mass? Right? How do we have to calculate it? That calculation part. Then what is the Avogadro's number? What is the mole? What is 1 mole? Gram atomic mass, gram molecular mass, that all things we have to see in this chapter. Actually, it's a concept. It's not the whole chapter because it's just a part of that chapter. Even after that, we have to learn about the stoichiometry. Okay. And it's a part of inorganic chemistry. So in the syllabus of chemistry, we are going to learn about around 2 chapters of inorganic chemistry, 2 chapters of physical chemistry, and 1 chapter of organic chemistry. Organic chemistry is 1 chapter already you have learned in your grade 10th. You must be recall it as a carbon and its carbon compound, right? Carbon and carbon compound. Just now you might have studied and gave your examination in a grade 10th. Correct?
Yes, ma'am.
Yeah. And the last 2, like ethanol and ethanoic acid, about it also you have learned, and IUPAC nomenclature also you have learned in that. So we're just going to go deep in the organic chemistry's chapter in grade 11 about the nomenclature, means how to decide the name of compound or any of given organic compound, right? And it is a universally same technique, and that is followed a rule which is set by one organization. Which organization it was? You have learned in your grade 10.
IUPAC.
What is this? Huh? IUPAC. It's a IUPAC. What's the long form of this? Huh? It's an abbreviation, right? What would be the what would be IUPAC?
International Union of Chemistry.
International Union of Pure and Applied
chemistry.
Yes. Please write down somewhere. It's very important. What it is? International Union of Pure and Applied Chemistry. Okay. And the short form is IUPAC system. Okay. So basically, what is the role of this system? It decide a chemical name for the compound and which is worldwide accepted. Means if I say, suppose methanol, here as a methanol. So if you go at the Antarctica, if you go at the North Pole, South Pole of the world, then too the name would be same for that particular chemical. Understood? And hence it is very standard system to give a name and even to decide the units of physical quantities in the physics as well as in chemistry. Okay? Understood? Yes or no?
Yes, ma'am.
Understood or not? Come on. I
Yes.
need your say, communication from your side as well. If I speak one way, that will not be helpful. Clear? Understood about this?
Yes, ma'am.
International Union, yeah, of Pure and Applied Chemistry. Fine. Now what we are going to see? We are going to see about the atom. What is the atom? You know that matter, right? Matter is made up by, can be classified. Matter can be classified as a pure and impure matter, correct? Pure matter is further classified into two parts. That would be element and compound,
Compound.
correct? Right. And the impure matter is nothing but the mixture. Impure matter is also called as what? Mixture. This mixture is made up by addition of two or more pure substances. And it is further classified into homogeneous and heterogeneous mixture. Correct? Yes or no? Fine. Now, what is the pure substance? What is the pure substance? Can you give me example of pure substance? Come on, tell me example of pure substance. Datri,
H2O.
Pritam, this one. Yes, yes. What?
Water, H2O.
Water. Okay, H2O. It will come under compound. Okay. Any element? Any element can you tell? Pritam?
Platinum. Platinum.
Huh?
Platinum.
Platinum. Okay. Fine. Carbon also will come under it. Oxygen also will come under it, right? Because it is element, right? So element means what? Element is a same kind of matter. Means all the individual entities present into the substance, if it is identical, then it is called as element. Okay. And if it is made by two or more atoms, then it is called as compound. Okay. In a fixed definite proportion. Okay. Very important thing is there while forming the compound. The atoms of the different element combine in a fixed ratio or in a fixed proportion, then only compound will form. And in a mixture, two pure substances thoroughly mix with each other in any proportion. There won't be any sort of fixed proportion. Any proportion they mix with each other, and hence it is mixture. It won't be compound. And they are not chemically combined with each other. They are just physically mixed with each other. And hence they retain their original property in the form of mixture. For example, if you take a sand and iron fillings had its own property. It get attracted towards magnet. Sand will not. And if you rotate the magnet over it, what happen? Only iron fillings will be get attracted towards it and sand remain as it is into the beaker or whatever what you have chosen. Correct? This all you have means like practiced in your school life. Correct? And even analyze. Yes or no? Yeah?
Yes, ma'am.
Yeah. Fine. This is a basic thing. Now we are going to learn about the atomic mass. Correct? So if I say about the mass is a physical quantity, correct? Yeah. We'll go little inside the physics. Let me know whether it is scalar quantity or a vector quantity. Please tell me, mass is a scalar quantity or a vector quantity, and what is the basic of scalar and vector? Come on, tell me.
Scalar. Scalar.
Scalar.
Scalar. Why?
Ma'am, it
Why
can be
scalar
measured.
quantity?
Just has
Only
magnitude.
Only magnitude.
Has a magnitude. If any physical quantity has a magnitude and a direction, That time we called it as a vector quantity, correct? So vector
Yes,
quantity
ma'am.
is always with direction. But then in a mass, we just have what? Magnitude, and hence it is scalar quantity. Correct? Yes? Yeah.
Yes, ma'am.
Now, here see, atomic mass is also a scalar quantity. But then atoms are very, very small, which we have learned in your grade 9, in your grade 10, which we are not able to see with your eyes, correct? Even it is very difficult to see them with the electron microscope, right? Yes or no? And for that reason, these atoms' mass cannot be measured in a gram or in a kilogram. Can we measure it in gram or kilogram? No, because it is too small to measure it in a gram and kilogram. And hence, we need a special unit to measure the atomic mass. And that is nothing but relative atomic mass. That is, and the unit which you use to measure that is nothing but AMU. What is the AMU? Atomic mass unit. What is the AMU? Atomic
Atomic
mass
unit.
Earlier name for that was AMU, and nowadays we called it as a unified mass. Okay? Understood? Yes or no? Means suppose I have to like write the atomic mass for carbon. Atomic mass carbon is nothing but a 12. So I will write what? It will be 12 unified mass, 12 units. Okay? If for the nitrogen it is 14, then I'm going to write 14 units. Right? Yes or no? And if I have to write for the oxygen, it will be 16. So I'll write 16 unit. Clear? Yeah. Please speak loudly because I'm not able to hear any one of you. Understood?
Yes, ma'am.
Yeah. Now, what we are going to see further in this chapter, what is the relative atomic mass and how to find it. Very simple example you have learned in your grade 9. I'll just recapitulate it. I don't know whether your teacher has been explained you or not, but then yes, I would like to explain you that simple example, which will help you really very well. Now, suppose I have a watermelon of a mass 12. Somebody is disconnected, I guess, right? 12 kg. The mass of this watermelon is what? 12 kg, right? And in one basket, I have an apple 1, 2, 3, 4, 5, 6, 7, 8. Suppose 10 kg around apples are there. And I just have to count only 1 kg. And I have just these two things with me. I have one watermelon with 12 kg. And I have one carrot of apple. It contains 10 kg of apple. And I just want to weigh 1 kg among. What exactly I supposed to do? What I'll do in this case? I will cut this watermelon in 12 equal parts. Correct? Yes or no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Suppose these are the equal pieces. Assume it. Okay, my drawing is not too good, but then you assume it's an equal part. So as it was a 12 kg and I have make it, means like I have made a 12 equal pieces. So each piece has a mass 1 by 12, right? That is nothing but 1 kg, right? 1 by 12 piece has a mass nothing but 1 kg because total mass of this watermelon is nothing but 12 kg. So I will take one piece of this watermelon. I'll keep it one side of the balance. Okay. Right. And other side, I will weigh the apples. How many it will be? Mostly 1, 2, 3, 4. Correct. That many would be there in that. Okay. And that would nothing but be 1 kg apple. Okay. In the same way, we have to calculate the atomic mass for the atoms. Okay. See how. So reference standard we need to take for that. And that reference standard is nothing but carbon. What is the reference standard? What is the reference standard, students? Just now I said. Am I audible? Vedika, what is this? Anybody? Huh? Pritam, what is this? It's a carbon. Its atomic
Sequence.
mass 12. Correct?
Mm.
Yes?
Yes, ma'am.
Yes or no?
Yes, yes.
Its atomic mass is 12. So what we have to do, we have to consider it as a reference standard. If you take 1 by 12th part of the carbon atom, okay, with a carbon 12 isotope, it is considered as a 1 atomic mass unit. Okay. If you take the mass of hydrogen, atomic mass of hydrogen is 1 unit, right? It will be nothing but what? 1 by 12th part of carbon 12 isotope. Understand? Means the atomic masses of the atoms would be compared with a 1 by 12 part of the carbon 12. And on the basis of that, we decide its atomic mass. One more example I'll let you know about the oxygen. If you take the oxygen, its atomic mass is 16. Why its atomic mass is 16? Because to balance oxygen atom, you need to take a 16th 1 by 12th part of carbon 12. Because 1 by 12th part of carbon 12 is nothing but 1 unit. So how many you take to balance oxygen? 16. And hence atomic mass of oxygen is 16. So nitrogen has a 14 atomic mass. Why nitrogen has a 14 atomic mass? Because how many parts? Sorry?
To balance.
To balance. How many parts of carbon 12, 1 by 12th part of the carbon 12 would be required to balance nitrogen? 14 parts would be required, and hence nitrogen has an atomic mass 14. Clear?
Yes, ma'am.
Clear? Yes.
Yes,
And hence this is nothing but a relative atomic mass. We have relate it with the 1 by 12th part of the carbon 12. Correct? And hence it is relative atomic mass. Clear?
Yes, ma'am.
Yeah. Now we'll move forward in the mole concept. I hope you understand the relative atomic mass. Yeah?
Yes, ma'am.
Yeah. Everybody. There are 4 questions. I think 4 messages. Let me check. Avogadro. Okay. Very good. Few of students, they have just gave me reply through the messages as they are not able to use their mic. Now we are going to learn about the mole directly because that is quite important, right? 1 mole of any substance would be what? I'll let you know. Suppose I know the atomic masses of the atoms, right? Just now I have told you hydrogen atomic mass 1, oxygen atomic mass 16, carbon atomic mass 12, nitrogen atomic mass 14, correct? Any other atom? Which helium atomic mass 4, correct? Yeah. These are the atomic masses for the elements, right? So atomic mass of any of the substance, when you express in terms of gram, that is nothing but a 1 mole of that particular substance. Means if you take 1 gram of hydrogen is equal to 1 mole of hydrogen, right? If you take 16 gram of oxygen, that is nothing but what? 1 mole of oxygen. If you take 12 gram of carbon, that is what? 1 mole of carbon. If you take 14 grams of nitrogen, that is what? 1 mole of nitrogen. If you take 4 grams of helium, that is what? 1 mole of helium. Correct? Yes? Just one?
Yes, ma'am.
Yes, ma'am.
Yeah. Understood?
Yes, ma'am.
Yes. Dhatri, Vedika.
Yes, ma'am.
Okay. Now 1 mole of any substance, 1 mole of any substance consists fixed number of particles. That particles can be atom, molecules, or ions. Now here we are speaking about the atoms: hydrogen atom, oxygen atom, carbon atom, nitrogen atom, and the helium atom, correct? So
Mm.
each and every 1 mole of the substance, okay, of element will be contain how many? 6.023 into 10 raised to 23 atoms. Correct?
Mm.
Yes?
Yes,
What
ma'am.
is this? It is called as
Avogadro's number.
Avogadro's number. It is called as what? Avogadro's number. Clear? Yes?
Yeah. Mm.
How many atoms of oxygen will present in 60 gram of oxygen now?
12 into
6.023 into 10 raised to 6.023 into 10 raised to 23. Similarly, if I gave you 12 gram of carbon, that will be the 1 mole of substance, correct? It will also consist how many atoms? 6.023 into 10
23
raised
into
to
10
20.
power 23.
Yes, this is the beauty of chemistry. You can understand, right? If you take an atomic mass or if you take a molecular mass of any of the substance, whatever would be the gram, okay, that is a 1 mole of that substance, and 1 mole of substance consists same number of particles, that is 6.023 into 10 raised to 23, and that is called as Avogadro's number.
Number.
Okay, understood? It is denoted by N0 or NO. Okay, clear?
Yes, ma'am. Yes, ma'am.
Okay, fine. We'll move forward now. Shall I erase it or you would like to write?
Return.
Okay, fine. I'll give you a few examples. Okay. Let me see whether you're able to do it or not. Can you do this?
2 moles.
Just one. Dhatri, Vedika, Pritam. If you face
2
any,
moles.
please speak up so I can help you. What you have to do? 28 gram of nitrogen is given to you, but then nitrogen gas is given to you, right? That's not a
Number.
nitrogen.
Avogadro's number.
So basic difference in between nitrogen gas, it doesn't contain only atoms, it has molecules as well. So that difference you have to keep it in your mind. If gas is given, you have to consist it as a
N2.
molecule. Yes, N2. Correct? Yes or no? And whenever you have to consist it as a N2, that time you have to calculate its molecular mass. Correct? Yes. How many atoms of nitrogen are there?
2.
2. Atomic mass of nitrogen? 14. 14 twos are 28 grams. Okay. Yes. So 1 mole of nitrogen consists how many grams? 28 grams. How many grams I gave you over here? 28 grams. So how many moles are there? How are you going to calculate moles? Number of moles
28,
equal
28
to
by 0.0233.
gram molar mass upon Avogadro's number, or given mass upon
Avogadro's number.
given mass upon gram molar mass. Sorry, here. I'll write it. Given mass upon gram molar mass. That will be what? 28 I gave you. 28 which already we have calculated. Both get cancelled. You will get 1. So 28 gram of nitrogen is nothing but what? 1 mole. Clear? Yes?
Yes, ma'am.
And 1 mole of anything will consist how many particles? How many molecules of nitrogen would be here? 6.023 into 10 raised to 23.
3.
Correct? Yes?
Yes, ma'am.
Clear?
Yes.
Yes or no? Suppose they ask you to calculate the number of atoms or number of molecules present into the given substance. First of all, you have to convert it into the moles and need to be multiplied by what? Avogadro's number.
Sir.
Okay. Fine.
Yes, ma'am.
Clear? Shall I give you a few more questions?
Yes, ma'am.
Can you solve by yourself now? Yes
Okay.
or no?
Yes, ma'am.
You have to try. You have to try. Okay. If you face any difficulty, you can ask. And if you can't speak up, if your mic is not working, you can text me. Okay. Fine. So I hope all of you are able to calculate the molecular mass if atomic masses should be given. Yes?
Hmm.
Yes or no?
Yes, ma'am.
Come on.
Yes, ma'am.
Yeah. Now calculate these basic things now. Can you do that? Second.
Five grams the first one.
Huh?
100
5 moles.
5. 500 by 100.
5 moles. 5 moles and the number of molecules. I asked you number of molecules, not about the moles. How are you going to convert it into the number of molecules?
Oh,
Hmm? You have to multiply it with what?
Avogadro's number.
point.
Avogadro's number. What it is?
6.023 into 10 power
0.023 into 10 raised to 23. Correct? So 5 into 6.023 into 10 raised to 23. Do the calculation. And while solving, please focus on this. Whether you are, they have asked you atoms or molecule. It's very important.
0.011.
Sorry. Yes, Preetham, you said something.
Yeah, we calculated.
Sorry, I'm not able to hear you. Can you please speak a little louder?
Calculating one.
Still not able to hear you. Please text.
Ma'am, 30 point.
Mass. Okay. What you have calculated for the oxygen? Mass of 3.022 into 10 raised to 23 atoms of oxygen. Atoms been asked. It's not a molecule. Think. How you will calculate it? Atomic mass of oxygen.
16.
16.
What is the atomic mass?
16.
16, correct? Yes, it's
16.
atomic mass. Now, number of atoms are given. What it is? 3.022 into 10 raised to 23, correct? Yes or no? 1 mole is equal to how many? 6.023 into 10 raised to 23. What you come to know by looking at this? It's just a half. It's just a half, correct? Yes or no? So half mole, right? 0.5 mole multiplied by, sorry, how you're going to calculate the mass, given mass? Mass of the substance is equal to given number of particles 3.022 into 10 raised to 23, correct? Divided by your Avogadro's number 6.022 into 10 raised to 23. This is a mole, correct?
Yes, ma'am.
Yes or no?
Yes, ma'am.
That is equal to 1/2, 0.5 we can say approximately, correct? Yes, 0.5 mole, right? So 1 mole is equal to 16 gram. So 0.5 is nothing but what? Half. So you need to multiply it by half. 8 gram. Yes. Clear? 2 ones are 2. 2 8s are 16. Clear?
Yes, ma'am.
Yes, ma'am.
Understood? Means Avogadro number, gram molar mass, gram atomic mass, and the number of atoms or particles present in the given substance. These all terms you have to rotate as per the need of problem. Okay? These all need to be revolved as per the need of problem. Sometimes they may ask you only to calculate the mole. Sometimes they may ask you to calculate the number of particles or number of ions, number of molecules or atoms present in that. But then molecule and atom, what exactly asked, that need to be focused, because when molecule would be asked regarding the gas, that time they will give you nitrogen gas, oxygen gas, helium gas. They will not specify about the atom. But then when they ask specially only for the atom, that time only atom word is given. And you need to take atomic mass at that time. You need not to take molar mass. And if you take molar mass or molecular mass, they would be the mistake. Okay? Please take these things in your mind always. Clear? Fine. I hope about mole concept I have cleared. Yes?
Yes, ma'am.
Yeah. Means basically general one simple chart I'll give you. Please write it down. Okay. And related to this 5 questions I'll post to you that you need to solve by tomorrow. Generally, if somebody give you any substance, what you have to do, you have to check whether it is atom or molecule first. Correct? If it is atom, there won't be problem. But then if it is molecule, you have to check whether it is diatomic molecule, triatomic molecule, tetraatomic molecule, or polyatomic molecule. Do you know this or not? It's all about atomicity. What is atomicity?
Number of
What is atomicity? Number of atoms present into the molecule of substance. Correct? If you don't know, please write down. What is atomicity?
Number of atoms.
Yes. Number of atoms present in molecule. Okay. You have to check after checking the molecule whether it is mono, di, tri,
Right.
tetra, or poly.
Poly.
Yeah. So example, shall I give one example for each? Mono means only one atom. Like generally noble gas, you know, noble gas, helium, neon, these all are monoatomic gases, right?
Mm.
Then diatomic, oxygen, nitrogen, right? Then the triatomic would be what?
Right.
Triatomic, ozone. Tetraatomic is a phosphorus, P4. And the polyatomic, if we say more than 4, would be sulfur, Sn. Correct? Yes or no? Fine. So after checking that, you have to calculate its, means like atom, if it is, you have to write its atomic mass in grams. Okay? Right? And if you have to take the molecular mass, if molecule is given, that also you have to take into the grams. Correct?
Mm.
And this is nothing but your 1 mole of that particular substance. And it consists how many particles? 6.023 into 10 raised to 23. Okay, particles. And now these particles are nothing but atoms, molecules, or ions. Clear? Fine. If your atom is given, then the number of 6.023 into 10 raised to 23 atoms would be present in your given substance. If they ask for the molecule, 6.023 into 10 raised to 23 molecules are present. And if ions are given, that time you have to write 6.023 into 10 raised to 23 ions. Clear?
Yes, ma'am.
Okay. If you have any query, any question, please ask.
No.
Any query about this concept?
No.
Yeah. So basically, like I hope you have written this sequence. Yes or no?
Yes, ma'am.
Wrote?
Yeah.
Yeah. Fine. I'll give you a few formulae that you need to write down. Or else I'll simply come down. That will be easy. Okay. Yes. Number of moles of any substance is equal to given mass upon gram atomic mass or gram molar mass. Again, number of moles equal to given number of particles upon Avogadro's number. Correct? Yes. And the Avogadro number is denoted by N0.
Oh.
And then given particles denoted by N. Okay. And number of mole is denoted by small n. Clear?
Yes, ma'am.
Yes.
Yeah.
So if suppose among these three, any two are given, like suppose gram molar mass is given, sometimes they won't give gram molar mass, they'll just give you atomic masses. You need to calculate it. Okay. Number of moles would be given. You can calculate the given mass. Sometimes they will give you just the particles and they ask you the number of moles. So Avogadro's number should be there in your brain always. That is 6.023 into 10 raised to 23. Okay, you can calculate it. It's very simple, very basic, because if you know this, then only we can move further. Okay. And hence I have repeated it 2 to 3 times. Clear?
Hmm.
Yeah. Please write down this. I hope you have written.
Yeah.
Anybody have any doubt and query?
No.
No. Sure?
Yeah.
Fine. Yeah. Shall we stop now then? I hope time is up.
Okay,
Is
ma'am.
it? Okay. Fine. So I'll post few questions. All of you have to solve it by tomorrow. Clear?
Hmm.
Homework has written or not? Okay, let it be. I'll do one thing. I'll post few questions in group itself. There only you solve. That will be the homework, and the test you have to solve by tomorrow. Clear? So have a great day. Bye. Take care.
Bye, ma'am.